And then you continue 1, 2, 3, 4. 1, 2, 3, 4, and so on. And then you have again to make 2 additional lines on the outside. And then you continue 1, 2, 3, 4. 1, 2, 3, 4. So something like this, and then another additional toolpath. And that is what I want to show you now. So this is, let's say, the next exercise. Okay. So we are still focusing on printing walls. Okay. So let's make a new layer group. Let's keep the file and let's make a new layer group. New layer group and call it lengthwise, or what did we say in the presentation? It was in the strategy overview. Multi-track single beat. Multi-track single beat. Okay, let's call it multi-track single beat. Multi-track single beat. Okay, and then we name this single box, and another layer for the toolpath. Toolpath single. Then we can make toolpath doubled. So these are the doubled contour lines or toolpaths. And then we will sort them together. So TP all sorted like this. Blue, TP doubled, I don't know, cyan, and this one, maybe, I don't know, skin colored. Okay. The box here, I don't know, dark green. And the other stuff, I will switch this off. Okay, I can blind this out a little bit, that I have a better overview. Okay, so let's create the box. Single box, CAD, and select the box. Can take the settings like we did before. Completely okay. And I click OK. So now I have the box created. And I will switch off the machine. And then I go to my TP single layer, activate this. Okay, by the way, because I see the logs here, let's click on a log. So the single box I just created, so we see this. And I close the log for the single box. And when I now want to click inside the screen here, I can't select this anymore. Okay, so maybe one day you have problems to select something here in the screen. It can be that you close the log. But even when it's closed, you can click here in the workspace on this element. Okay, but I recommend to not use the logs so often. But as always, it depends on the user, what he likes most. Okay, TP single is selected. So we want to create toolpaths for the single box. Sorry. And I select a box and go to CAM3DMP, and again, volume built up in layers. Okay. So torch, we don't need to change something because this is saved. This is what we need. So we start with the tag tab. Fill tracks only. Yes, we only want to fill this. And the strategy for infill tracks, we will use hatching bidirectional. So then infill options. So we want to create lengthwise toolpaths. Means we go to angle step. Starting angle is 0. Okay, because it's in X direction. And we want to have it this way. I let it remain here, the 180. We will see later what the start-stop point distribution is doing. Okay. Click OK. Click calculate. And you see I still have my process markers on off. And you see I have in each layer only one start, one stop. So actually this looks like a meander, and it is a meander. Okay, if you use hatching bidirectional or meander, is actually the same. The developer guys, they told me, no, this is different, but they never could show me what is the difference. Okay, so when you go hatching bidirectional, I think when somebody is working with a part, at least for him, it's better to understand what is the strategy you wanted to use. So hatching bidirectional. And then we go to the process tab. And here we scroll down directly to in-feed motion with active process and disable this. Click calculate. And then it looks like this. Okay, I let the same settings like before. Okay, so no, this makes no sense. Let's make a track distance of 3.5. So track distance, basic values are between 3 and 4 millimeters in the most cases. So make it 3.5. And then we see our stop point distribution is not perfect. Please try first to achieve this. And then we try to improve the start-stop point distribution. So I go to infill options and change the angle step to 0. Click OK and recalculate. And you see actually nothing happened. So I activate mirror every other layer. So it's like trying a little bit around, okay? I also doing this when I have projects sometimes to just play a little bit with the values. And when you see here, mirror every other layer, this works pretty good. So now you have start, stop, start, stop, and the next one is like stop, start, and so on. And this is actually what you want to have. So on the infill options, I have starting angle 0 and I activated mirror every other layer. And I clicked OK. So actually that's it. So we can switch to advanced, check our values, but it's remaining the same like before. And we can click OK and have created the base tool paths. So I don't know why, but in the very most cases, we make in the fourth layer, in every fourth layer, double lines on the outside. Okay, so in the fourth layer, so you see here. Well, let's have at first a look what is a layer and what is a weld. Okay, therefore I will save this and I create then a G code. Go to post processor box 2 multi angle bead. Go to edit, and then you see you start with the first layer. And directly you print the first weld. So you print the first weld. Then comes the second weld. Then comes the third weld. Fourth, the fifth, and the sixth. And then comes layer number 2. And then layer number 2, you continue with weld 7. Okay, so means when I close this, see you have here 1, 2, 3, 4, 5, 6. And then you change your layer height. So the torch is going upwards with a value of 1 layer height, and then it's 1, 2, 3, 4, 5, 6. So we also can go through this here with when we open the plus next to our toolpath group in the workspace. Then we can select here the first element, and these are the welds. And these are the indexes of the welds inside of the toolpath group. So when you now click on the down arrow on your keyboard, you can go easily through the part. So first 6 welds are 1 layer, and then continue like this. Okay. So we will use this again later when we have sorted, and we need then to check this. Okay, so what we need now is we want to create the doubled tool paths. Therefore, we need a function called track polylines. So this function here in the upper area. And then we go to the outside here and we count 1, 2, 3, 4. Okay, I want to have here a doubled line. Click on this element. You see something happens there. And then I click OK. Okay, I put it on the wrong layer. So actually I want to have it here on TP doubled. And I select this layer. And then I go to move to layer. And then you see here this cyan colored thing. And then again, I open track polylines and make the same thing on the other side. Maybe I switch the direction. So you see it's kind of a arrow. So here's the sphere is the start point, and on the end you have kind of an arrow. It means this is start, this is end, and it's good to have it in the other direction than you have it here. Okay. So you can click OK, and then you have a second one. What you already see is that when you have two elements lying over each other, one element kind of blinds out or blocks the view on the second one. So that's the reason why I like to shift a little bit my doubled paths. So actually it's no tool path currently, it's only a contour line. And these two contour lines I select here in the workspace. Then I go to move copy. And select the mode move. Go to Y, set it to 0, and Z only a small value, so like 0.1 or so. Click on calculate. Okay. And then you see the little difference here. It's more jumping into the eye, and this helps a lot later to see things like this more fast. Okay. So we can blind out the TP single stuff. And the box also, if we want to. Now we have two lines. And the thing is, I want to make tool paths out of it. And at that point, I want to show you how to make tool paths out of just line elements, or contour line elements in this case. I want to. Okay. I opened the presentation for the box. So it's a training material CO4 box. Maybe you have it already open. And then on page 31, you have kind of the single steps when you come from a line element to contour line to a vector contour to a toolpath. Okay, so you need to do these steps. So I think we might have already a contour. Yeah, see, we have a contour. And this can close. So there are 4 types of elements. Okay, you can have a line by itself. It starts with a G, whatever is the reason to use a G for this. Then you have a contour. This is the next evolutionary step, you can say, okay? So it's like you in a line, is it like you have 2 points, but he does not understand what is the start point and what is the end point. Okay. And then when you create a contour, you give him the information. Okay, this is your start point here, and this is your end point. So you can also check this by clicking on curve start points. When you have an arrow like this, you see, okay, this will be your start point, end point, start point, end point. Okay, when you don't see this purple arrow, also this is selected, then you have here a line element. But you also can see this with the capital letter. Okay, so we already have an contour line element. So now we want to have vector contours. So what is a vector contour? A vector contour has in each point a local coordinate system. And related to the coordinate system, later the torch does know how the torch has to reach this specific point. So in what position he should reach the point here. So you can go from top, you can come from the downside. So the definition, it's at first it's free what you decide, and you have to say to them, okay, this is your Z direction. So we mainly focus on the Z direction. This is the most important one because out of this direction is the torch approaching to the part. Okay. So we need therefore a reference where we can say him, okay, take this reference for your Z direction. Okay, and the reference I prefer to use is a reference plane, because when you have a surface or plane, you have a vector normal. So every surface has a normal, and this normal we want to use to create vector contours. Okay, so let's create first a reference plane. So for instance, I grab here CNC3 and rename this to reference plane. Maybe I give it another fancy color, like this blue, purplish something. And then I will draw a circle, and from the circle later I can create a surface. Okay, so let's draw at first a circle. We go to the circle function. And then under create, please select curve. Okay, when you first started the software, you might have this, but you want to have curve so that the curve is already a contour line, because otherwise you have to make first a circle, then you make the contour line, and then you make the surface. And so we save one step and can work a little bit faster. So when you set this once, it is always saved. So the radius of the circle, the radius of the circle doesn't matter. I recommend to take a bigger one, so like 200 millimeters, so 100 millimeters, so that you have a diameter of 200 millimeters. And then you don't know where to put the circle at. Okay, you can click here on a specific point or so. I like to use the keyboard. So you see we have here again in the lower left area the snap functions, and I like to use the keyboard input. And then you can relate it to this coordinate system, type in here values, so a coordinate, and I like to put my reference plane 20 millimeters below the global coordinate system. So it's like, then I definitely know that this is only a geometry which shall help me, and this is no geometry of the part itself. Okay, because the part should be always be above my coordinate system. So it's like workflow I use or we use in GEFATEC. Okay, I use absolute Cartesian coordinates and I click OK. Then I close this and I have a circle here. And you see you have the purple arrow here, or in my case I have it because this is activated. So this means this is also a contour line. And when we want to have it a surface, so we will find in the lower left area or in the middle, but more to the left, there are the surface functions. Okay, all surface functions, whatever we will use, need, or whatever, are collected here in this area. On the right side, these are vector functions. Okay, we need later, mainly when we work. No, actually, we need this in a few seconds. But now we need the surface functions, and we need a specific one. We need planar face bounded by curves. So this one here, like the dice or whatever, like the box. Okay, we click on this. And he's saying to us in the lower left area, pick curves. Okay, then let's pick a curve. We pick this one. And now this is not grayed out anymore. We can remove old objects. So then he will delete the circle we created because we don't need it anymore because we have then the surface. Okay. So we click OK. And we have a surface. If you don't see a surface, maybe you have activated the teapot. So now it's wireframe mode. We go back to shaded mode, then you see the surface. Okay, and each surface has a normal. So the normal here would currently point upwards, but we can't see the normal. Okay, actually I wanted to have the surface on the reference plane. So I select my reference plane and move to layer, to reference plane. So I can it more easily switch off then. Okay. So let's create vectors. So now we have everything we need to create local vectors on our contour line. So this is what we want. Okay, I select my vector contour, my contour CO5 and CO6. And then I go to this function. I call it often the red eyelashes. So sometimes I think it's better to understand what I mean. And the red eyelashes are called actually assign vectors to mesh net vertices. Okay, click on this. and then a window pops up and you should select from underlying surface. So whatever are the other functions here, I never ever used another one than this. Okay, so I think for 99% of everything you need, you will use from underlying surface. You can delete all objects. This is okay because we don't need the contour lines, because we have then vector contour lines. And you get the information that you have curve with 2 points already selected. And here in the lower left area stands pick face or 2D polyline with depth. So we have definitely a face. This one, we click on it. Now we can click on calculate. We don't see much, but when we click here in the upper area on facet normals on off, so the purple eyelashes, you see now local coordinate systems. You see Z points upwards like the normal of the surface, and X and Y, it's kind of, yeah, the one shows here this side, the one shows in this side, because the one line is going this direction, the other one this direction. But that's no problem. Okay, that's completely okay. Focus on the Z direction. I click OK, and now I find here FO2, FO3, the vector contour lines. Okay, so the next step, we have this, and we want to have toolpath. So we want to create a toolpath. So what is the more information the toolpath have than a vector contour? Here the toolpath have also feed rate of the torch, the job definition, the safety distances, and the tool orientation. Okay. So we select FO2, FO3 here in the workspace. I hold the control key or the shift key to make a multiple selection. And then we can go to, yeah, TP double. I activate this one. And then I want to create the toolpaths. So toolpaths, like I told you, every time we want to create toolpaths, you need to go to CAM3DMP. And in this case, even when it's 3-axis, it's not that we use volume built up in layers. At this time, we have as input vector contour groups. And when we have vector contour groups, then it's only possible to work with multi-axis machining. So I click on this. And then we are here under the tag tab. You see there is not much what you can select. We go to the tab lead in and out. And actually, this is a tab you will never use. Okay, please check if you have none, none, shorten, shorten, and then never ever have a look in lead in or out. This is also kind of milling stuff, which is not good for our process. So, and then we go to the process tab. Okay, the process. Temperature control. Yeah, we definitely want to have temperature control before track 150. So like the settings we did for the main tracks. And the feed rate should also be the same. I don't know what it was. I think it was 1200. And the job number, I don't know, maybe it was 86. I'm not quite sure, but I think so. Okay, you see the layer thickness, you can give him no information because he only wants to directly drive these lines here. Then we go to positioning plane. And please definitely set this to none. Okay, when you use 3DMP the first time, I think this is activated. Please set this to none and never ever change the settings here. So there's also stuff which is under development, and this will create currently wrong position movements between the welds. So every time, none. Then we can go to advanced. And here we find our basic definitions we already made. So we can save this like it is, and then we can click OK. And then you see we have created tool passes. You see here the safety and relief distances. And when you have a closer look to the workspace, you see that you still have the vector contour lines. And please delete them. Okay. The idea behind it is that you have a better selection when you have deleted the vectors, when you only have the tool passes. So I hope I was not too fast for you. So if I ever are too fast or I should wait or so, please just say it, okay? Because I know that I'm often a little bit too fast for the training attendees. Okay. So you see that we have here our double tool pass, but only in the 4th layer. So we need actually also in the 8th and in the 12th and in the 16th layer. So what we do now is we copy this, but we want also to have a good start-stop point distribution. So it means when I have here layer 4, I make only one copy of this pair to layer 8. Okay, and then I switch the direction of the tool passes of layer 8. So I select the tool pass group, TO5, and make a copy with my move copy function. I create a copy, and like I said, only one copy. And for the Z value, I use the layer height, but 4 times. So I think the layer height was 3 multiplied by 4. We cannot type in here formulas, so we have to calculate it for our own. So it's like 12. We click calculate, and then when I zoom in, you see here in my layer 8, I have the tool passes. So I click OK. I see I have doubled them here. I switch off my original TP signals here. Okay. I also switch off my reference plane. I don't need this anymore. And then I switch the direction here of TO6. Because this is a group, because this is only possible when you have a group, you can right click on TO6. In my case, it's TO6, so on the second 2-pass group. And you can click reverse curve direction. They see my start and stop points here for the upper passes are switched. Okay. So then let's create the other 2 layers from the doubled ones. I select both toolpath groups here. I go to move copy, create copy. I think 1 copy is enough in this case, and we have to double this. Okay, because we have already 2 layer types here, so we double this to 24. Calculate, click OK. And you see here we have only additional layer on top, so this is completely okay. Then we save this. And then I would say we make a 10 minutes break. And after the break, we will sort this stuff and then we simulate this, create a G code. And then we will have a look what we also can do for today. Okay, see you in 10 minutes. Okay. Shall I continue? Okay. Yeah, we have created the toolpasses for the main wall, and we have created the doubled ones. And now we have to make a connection between of them. Okay, I want to print this first and then the doubled ones. I want to put the sorted toolpath on my layer TP all sorted. So I activate this layer. And for the connection of the layers, so for the sorting, I prefer to use merge slices. And you see he has an error message. So 4 objects improper for this function. And you see he deleted here the doubled lines. So what is the problem? When I right click on the first toolpath group of the doubled ones, you will find here something like convert to slice group. When I go to this one, which worked good, I right click on this, they don't have this convert to slice group. So this means I have to convert all 4 of this. And because I don't want to make this for each single one, so when you have 4, it's completely okay. But when you have maybe, I don't know, hundreds of these, you can make something like you select all, and then you create a group. So here's a button, it's called Form a Group. And then please use the same settings like I have it here. And then you can click OK. So you see he already switched the layer. So I switch it back to TP doubled. Move to layer. So that it's look like this. Then you have TO9. I right click on this. Convert to slice group. And when I again right click on this convert to slice group, it's completely vanished. It's not grayed out or so, it's completely vanished. So and then I can use these 2 elements and use merge slices. Okay, this is a pretty easy print. So we can sort in the Z direction. So I use the mode check for equal Z values already. I don't want to remove the old objects, but I want the new one to be placed on TP all sorted. And then I click OK. In my layer tree, I switch off the old toolpaths. And you see there's a little bug. So he's on the correct layer, but he did not get the correct color. So to get the correct color, I switch again, move to layer. And then it should look like this. And you see here, because we lifted this a little bit, the double tool passes, you see that here something is kind of doubled. Okay. Then let's check the results. Go to T10. And then start with the first element. So we're on the first layer. And go through 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Plus 1, plus 1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Next layer. 1, 2, 3, 4, 5, 6. Next layer. 1, 2, 3, 4, 5, 6. And the doubled ones. Okay, this is the way what shall look like. And I made it dark blue on purpose because when I have a lot of tool passes, you can see very good the yellow highlighting between the dark blue tool pass. Okay. In this case, there is also another option for sorting. Name this merge slices, and I create under multi-track single beat new layer TP all sorted, and I call it grouped. Okay, I make it also dark blue because it's more easy for checking. And I switch off the other one. And again, I activate our initial tool paths here. When I now select these both, so it would also work with the others where it was not grouped. But you can also use the group function for your sorting in specific directions. So you can also, when you select 1, 2, you can go to group, home group, and then you can go to unsorted, click on it, and say Z extending. Click OK. See, he directly got the color. And then you can check tool passes. So 1, 2, 3, 4, 5, 6. 1, 2, 6, and doubled ones. And so on. 6, 6, and the doubled ones. So you see this also works in this case. In the most cases, I prefer merge slices. Okay, for easy geometry like this, form a group is completely okay, but merge slices is the more powerful sorting function. Okay, but both is possible in this case. The main important thing is that he sorts correctly. Okay, when one is not working, maybe the other one will do. So it's good to have two options here. Okay, and then you can create a G-code if you want to. So you can select the toolpath group, go to CAM3DMP, and post-processor. Track single beat, okay. And then you see we have, so what is the difference? Yeah, that's also good. What is the difference when you use group and when you use merge slices in the G code. So you see, you have here only a definition for weld number 1, weld number 2. So there is no point for layer. So actually, he starts a layer here on the end of the toolpath. Okay, so it's a little bit different with layer and weld definition here. So this is a little bit confusing. And when you take this one with merge slices, this was created with merge slices. Then we'll have directly layer 1, weld 1. So all this stuff is better defined, because later for more complex parts, we will use these strings to maybe improve your stuff, to adjust safety positions more easily within the G code and things like this. Okay, and then you can use these strings as replacement strings and can put in front of each layer safety positions, etc. Okay, so it's always good to have a better structure in your G code, and merge slices has the better structure. Okay. So it's like I want to make something like it's almost like a repetition of this stuff. Okay, but it's a thing we often do in GIFATech to find the correct position of our toolpaths, of our print. So sometimes you plan that the substrate it's mounted like this and this, and on the machine, the guy on the machine mounted the substrate a little bit different because it was not other possible. Whatever is the reason. Okay, so means when you have, for instance, 3 walls. So I will copy this through 2 times. So yeah, okay, what we do. Okay, at first I say what we are doing. We're creating again 3 walls out of the toolpaths. And then the guy on the machine, he don't want to run all the walls each after each other to know exactly where the machine will print the walls, and if the substrate and the clamping system it's mounted correctly. So therefore we make kind of bounding boxes which we are not printing, but which the machine can drive, so that the guy on the machine knows where is my printing area. Okay, so that no collision or wrong printing or wrong referencing is used. So therefore, at first we create 3 boxes. So not 3 boxes, we copy the printed box here 3 times. So set a 0. We copy 2 times because the third one already exists. And Y direction, we make 50. So we use the move copy command, and we use these settings on this part. Click calculate to see the preview, and OK. Okay. We want now draw a box here around our printing area. So what I use there for is I draw line elements. Okay, I start from here, go to here, and so on. So actually, we make something like this. Okay, the line element. This time we start directly with the line element. Okay, I choose my line element. Maybe I put in here the name for, let's call it contour right. Okay, what's the problem? Function still open. Okay. Contour right. Select the layer. And then I go again into line and draw my first line element. Okay. The function is still open. So I can pick this point again, go to this one, and I have my second line element. You see it here in the workspace. Then you click here, go over to this point. That's it. And then this one. Okay, and then I can blind out my printed geometry. You see, it's kind of a bounding box I created. And now I have my tool passes, and I want to have my tool passes here, but I only have line elements. So this means we needed first contour, vector contour, and then we can make tool pass out of it, and then we will do another thing. But first contour. So we make the drag polylines function. Okay, here our circle pit or whatever this is. Drag polylines. Click on the first element. And you don't have to click every single element. You can click on auto. And then he's going by itself all the way around. And you can click OK. And because I have delete old objects, my line elements are already deleted in the workspace. Okay. So we have the contour. We need the vector contour. So this means we need a surface. But I still have here my reference plane. Like this. But only for making it more clear, I want to show you something and then I switch this back and then we can do this together. So please just watch what I'm doing now. I think then it's getting a little bit more clear with the coordinate systems here. So I switch on my coordinate systems, the purple eyelashes. So I don't have any. Then I select my C. So, I wanted to show you something, of course. I select my surface and let's say I rotate the surface, the underlying surface, about 45 degrees. So that it looks like this. We now click on CO5 and I sorry, and I go to the red eyelashes, go to my surface, click on calculate. You see, this is the same direction like the surface has. Okay. I don't want it to have it like this. I want to rotate this back. So minus 45. And then I have the state you should have currently. And then we can do it together again. We select the CO5, the contour group, assign vectors from MeshNet vertices, select the surface, the underlying one, click OK. Then you see X and Y looks a little bit strange, so it's like it's putting you in the middle something, but this is no problem. And now we want to switch from the vector contour to the toolpath. And already on this picture, you see that the X and Y direction, it's more focused to the tool orientation than on the X and Y direction from my vector contour from the local axis. Okay, there the main important thing is the Z axis. Okay, vector contour group. I want to make toolpath out of it. I go to CAM3DMP, multi-axis machining. Okay, we have normal to current frame, so standard stuff. Okay, under tag, there is nothing we can set here what is interesting for us. And process tab. Yeah, we don't want to print this, so we don't need temperature control. Okay, we can switch this off for the single weld here. And the feed rate, so the guy in the machine should not fall asleep, so let's increase the speed here to 2500. And job table 86 still working. And then we click on OK. I select my vector contour and I delete this. Why I delete this? Okay, I want to show you. I click here, so I have the vector contour and the tool path over each other. I click here. Okay, in this case, of course, this works, but often is that you are selecting something, you don't get this box, and then you think you are working with the toolpath group, but you are working on the vector contour group. Okay, so that's the reason why we don't we delete this, because we don't need this for any other function. And then we have the toolpath group, and everything is nice. Okay, actually, this is the toolpath group around our 3 boxes. And I want to create this as a G code. In this case, I will create a single file. Okay. So I only select the contour right and I call it box contour right. Okay, then I go to edit and have a look. And you see here, so of course you don't know this, but this M42 means he starts the arc and he wants to print this. And we don't want him to print this. It's only as a reference for the machine guy, for the operator. And what you can do is you can comment this out with semicolon. So actually this would be enough. You can also do something like this. but M42 is the one you should comment out. Or what you also can do, because sometimes maybe let's say you are on vacation and the other guy of your company has to work with the part and he did not understand that you don't want to print this. So to make it more fancy, more clearly, you can go to T14. This is our contour right. Go to CAM3DMP and go to Edit Vertex Comments. So I switch this off, and you see at first he's on the element, starting element with index 1. So there's a point up here. When you go to the second point, it's a point here. So actually here is the printing started. So you have here work begin, check. When you deactivate the check here, it don't start to print. So we click OK. So please on index 2, deselect work begin and click OK. And when we now run this with the post processor, replace please my file, and I go to edit, and you see we only have the movements. Okay, so nobody could make a mistake that he accidentally print the stuff. And in give attack, this already happened, that somebody printed this, and normally this is no big problem. But maybe one day it can be. Okay, so with this strategy, you are on the safe side. Okay, I will save this file. And then this should it be for the boxes. For the training exercise CO4, I think we have done here all the stuff what is inside of the paper, even some things more. And because we have a little bit of time left, let's start with thin wall. Okay, CO6. Maybe tomorrow then we start with CO5. We'll miss this. I would say we make this very small exercise. It's like it's only a thin wall, single track. We will create the wall with CAM3DMP environment so that you get more use into the functions and what to click, where to click and stuff, and so that you get more used to the workflow in CAM3DMP. And then we will create the tool paths for this. Start stop point distribution. So you see this should be pretty easy. And I don't think that you will have problems with this. So please close your file here and open a new one. Let's grab this time an ARC 605. Not that we need this for this part, but I want to see if you also have there the 90-degree rotation in the beginning of the G code. Okay, and you see this machine is a little bit bigger, needs a little bit more space. And we are now only slicing a very small part, but no problem. Okay. So how to create this wall? We will draw a line, then we will copy this, and then we create a surface on this between these lines. And this surface then we can slice. Okay. So that's the idea. Okay. So we have no substrate here, so we consider a height of 10 millimeters. So we're assuming to have a substrate with a thickness of 10 millimeters. And I draw a line. So I go to the line element. And I again like to use the keyboard input. So we give the x coordinate minus 100, for instance, and the y coordinate 0, and the z coordinate, this is the 10 millimeters for the substrate. We use absolute Cartesian coordinate system. Click OK, and you see nothing, because when you go with your arrow here inside of the part, you see something is grabbed. And when you have a closer look to the lower left area of your screen, you will find that he needs a second point. Okay, so we type in here plus 100 for x. I'm losing my voice. Okay. So 100, I again click OK, and there we have our first line element. And then I close my line function here because I only want to copy this. It's a little bit more easy. And I can switch off my machine like this. And then take my line element, go to the move copy function, and create one single number of copies. Set the y direction to 0 and the z direction, I don't know what's the height we want to print. 100. 100 sounds good. Click OK. So now I have two line elements. And I want to create next a surface between them. Both lines. And then measure it from U curves. Okay, you can use the base settings like I have them. So this is later for some kind of grid in the surface, but we don't work with this currently. So you can just take this and please make sure that this is not activated. Line curves is good. Delete all objects, also good here. And then you can click calculate, and you see you get something like a surface. So this is the function you want to use. Mission it from U curves. And then you selected both lines, you can create them. Okay, I will save this. Okay, when you have the surface, you can click on this, go to CAM3DMP, volume build up in layers. At first, I want to switch the layer because I don't want to have it also purple or magenta or whatever this is. I want to have the yellow ones here. Also can rename this to toolpath. And then you see here we have selected one surface from ZMin 10 to ZMax 110. And then we can switch to curve only. And when we create the curve only here, please select here only one, because here you have the option to make double lines. This is something we used in the beginning of GIFATech, but now the process is more stable. So actually we always need one time. And then let's have a look on the curve track options. Okay, spread starting points, yeah, can be activated. Actually, we have no closed contour. Okay, so this will have no effect. The other stuff, it's all deactivated, so actually you can deactivate all of this and click OK. So, and then you can go to the process tab. I don't know, maybe this time we have another layer thickness. For instance, 2.5. Seam width, whatever you want to have. Maybe 5. And then we have a look on temperature control, and here we can use, I don't know, maybe this is another material. Let's take 180, it's intermediate layer temperature. And offset regarding curve tracks. Okay, I have 3, so I calculate to show you what happens here. You see now I have a difference here of 3 millimeters. So you can use it to shift your tool passes related to a surface. So it's also when you type in -3, then he switched the side. Okay, but here we want to have 0 offset regarding edge curve and maybe a feed rate. So single track, it's a little bit more slow. So let's say 700 would be more real. And job table, I don't know, 651 maybe. And then you can go to advanced. And these are the same specifications like we had before. So we can click on calculate to see the preview. On the first view, it looks pretty okay. It's hard to see here. So maybe we go to the wireframe mode. So it looks a little bit more cozy. And then we can have a look on a start-stop point distribution. And you see we have all start points here and all stop points here. So that's not working. So we have to switch back to the tag tab. Go to the curve track options. And then we use opposite direction in every new layer. Can click OK. Calculate. So again, here we activated this function. Opposite direction in every new layer. And click OK. So that's it. Okay, this is a pretty easy thin wall 3-axis slicing. You can save this. And we also can have a look in the simulation. Go to the shaded mode to see the machine a little bit better. And I switch off the surface, so like this. And then I select my toolpath group, go to CAM3DMP, and I go to the mechanism simulation. Shortcut is also F7. And then I can click the play button. Increase the speed a little bit. And the trick with a space key for improving the speed here a little bit. You see that's the way it looks like. Okay. So I think it's time for questions. So actually it's the last hours you also could have questions. If we have now questions would be good. Otherwise I would end the training for today. I think it's not enough time to start a new topic. And I also think this was a lot for you. So I hope some things are clear. A lot of this we will repeat within other exercises. Yeah. Any questions? Repeat the CAD functions. I'm not completely sure what you mean. Do you mean when I go to CAD to shape and so to create a surface, okay? Then, okay, my system crashed because sometimes the simulation doesn't like me, but no problem, I saved the data. Well, I can make it from scratch. So I open the template, a new one. And then I created 2 lines at first. Go to line function. I go to the keyboard and I click y x minus 100. So I have created the first point of the first line. Type in here 100 and I have created the first line. Close the line function. Here I go to my objects tab and I make a copy out of this, a height of 100 millimeters. So, okay, now I have 2 line elements. Then I select these both lines and go to MeshNet from View Curves. I use these settings. It's not so necessary to have here the same settings, but specify distances is good. And I use align curves, delete all objects so that he deletes the lines because I don't need it anymore then. Please have this deactivated. Then when you click calculate, you see the preview of the surface. When I click OK, the surface is there. Okay, you have created a new VNet. Because when you click on this one, additional wires on off, you zoom in, you create a surface with kind of a net shape. Okay, this net shape we will use later for other stuff, but that's a way how to create in a short time a surface here. Or the other surface was done by creating a circle. Go to keyboard. Here, so this is the center of the circle, the coordinates. Click OK. Close the function. And then here was the planar face bounded by curves. So the small box here. When you click on this, then on the circle, click OK, you have the surface. Okay, when this does not work in your case, the problem is then when you create a circle that you have only this circle created, but you need to select this one here. So when I click on this, oops, and I use this one, I see a circle, but I cannot use this function. Oh, okay, they changed. Okay, oh, sorry, they fixed it. I also can create this on a normal circle now, but better to use create curve here. Do you have other questions, or is the question solved? Is the question answered? Okay. Any other questions? Okay. Then I would say I will finish for today and see you tomorrow at 9 a.m. Berlin time and 10 a.m. Moscow time. Okay. Thanks a lot for your attention. Yeah, if you still have questions also you can also write me an email or ask tomorrow. So no problem. Okay, then I see you tomorrow in the training. Bye.